Hello everybody, my name is Professor Soborno from Berry Times Lab. Today we're going to be looking at some more calculus. Today we're going to be looking at limits part 2. We're going to be specifically looking at limits with the graphs. So, hello Sir Isaac Newton. You're a nice visitor. You invented this for us. Thank you. Bye-bye. Now, first, let's introduce graphs. What are graphs? Coordinate plane, right? Do you guys know what a coordinate plane is? No? Well, okay. That's fine. Because a coordinate plane is basically just something used to measure the position of an object. This is just a basic explanation. There's the x, there's the y, there's the negative x and the negative y. I hope you know negative numbers, and if you don't, you shouldn't be watching calculus already. So, now, this is what a coordinate plane looks like. X basically measures how much to the right you go. Negative x measures how much to the left you go. Likewise, y measures how much upward you go, and negative y measures how much downward you go. So, let's say I put a point up, that's right over here, and that's going to be, well, let's count. This is 1 tick to the right, 2 ticks to the right, 2, 1 tick up, 2 ticks up. 2. So that's how to measure the position of a point. There's also the negative, which measure backwards. So now that you know how everything works, let's look at how this can be used for calculus. So let's say we have 2, 4, 6, negative, 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 and we're going to put the tick marks between 2, 4, 6, tick mark, tick mark, tick mark, 2, 4, 6, tick mark, tick mark, tick mark, and 2, 4, 6, they are negative, negative, negative. Okay, so now that we know that, let's move on to how they can be applied in calculus. So, we already learned limits. If you don't know them, go watch the last part. And let's say we take, I don't know, this function. I'm going to draw a funky line. Wait for me here, okay? Now, obviously, this can't be graphed with any kind of normal graph. It looks like an abominable hybrid of the sine wave and a very weird parabola looking linear line with the bows. So, it looks monstrous, but don't worry, things are about to get better. So, I'm going to make this part a little bit more flat. So, now, here, let's say we take the x-coordinate 4 and put some points up to it. So, let's start from the left. We're going to start from 3, and let's zoom in, and eventually we're going to get a little closer. Oh yeah, it'll probably be thick. Then a little closer, then a little closer, and eventually, let's see what we get. And right at 4, it approaches this number over here. And let's match that up over here. We're almost at 4, and that gets us to 3. So, this is how it's going to, this means that as x approaches 4, the limit is x approaches to 4, that's messy handwriting. The limit is x approaches 4 of equation f of x, we don't know the equation, is equal to 3. Because you can see that when it approaches 4, it gets closer and closer to 3. At this point, it's about, I don't know, 4.5. Then, at this point, we can say that it's a little closer to 4. And this point is right on 4. And eventually, you'll get this little turnaround to get you to 3. Got it? Good. And then we can also go the other way. Yeah, we'll keep going like this until we can also go the other way. We eventually get 3 again. However, there is one more weird concept over here. So there is one more weird concept, barely visible. Try something else instead. And this concept is going to look like this. So let's say we draw something over here. Don't worry, we won't draw the negative this time. So, let's draw another funky function. And what can we do here? So, well, let's say we go here, we stop right here, cut, and then we keep going over here. So, kind of like a weird looking tunnel that doesn't count as part of the graph. And now, this is all of f of x this time. And now, what we're going to do is there are 2 more symbols. So, limit, let's say as x approaches 5. The limit is x approaches 5. Well, let's look at one part first. When we go from the left, it's going to go boom, 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 bomb. Sorry, that's not about it, but it's close enough. And that's about at 4. So, it's x approaches 5, y is equal to 4. And let's verify this by going from the other side. And, okay, so we are going to start from here, get closer and closer to 5, until eventually our y coordinate is 5 instead of 4. What? A function can't have 2 outputs. So, how can we solve this? Well, there's a special way to solve this. What you do is you can either do x to 5 positive, which means you're coming from the right, just like in this scenario where you are coming from the right. Or you can do the negative to show you're coming from the left. Like over here, it was coming to the left. So now this problem has 2 solutions. And they can each be represented individually. Thank you everybody for watching, and I'll see you next time on Calculus. Bye! Oh yeah, I forgot. This video was sponsored by Brilliant. Go over there if you want to learn some new stuff or just want to challenge yourself on physics. You'll definitely learn something new. It's worth checking out. See you later. Bye!